Okay. So these wiring configurations, there are going to be some questions on the test about these. So you'll have this as backup. Forgot to hand it out. Here you go. There you go. Here you go. Here you go. Let me start off with you, and you.
And you. Oh, I thought it was
And this one's yours. This one.
And.
This one is yours.
That's it.
And.
Okay.
Boundaries are meant
You got 'em
to
now?
be pushed.
Okay. Okay, so the wiring configurations we're gonna do. We're gonna start off with this one, the shady pole.
Shady pool. What? That's a odd name, but okay, continue.
Shaded pole, because that is a shaded pole.
That's a shaded pool.
Yes. The shaded pole is the pole that has a copper band around it.
Oh, okay, yeah. The one that was a 4.
Yeah. Yeah.
Okay.
Single phase, L1, L2, only one winding on the shaded pole motor. Okay? It has low starting torque and low running torque. These are very inefficient motors. They're also very popular. Okay? You're gonna see these in refrigeration equipment for condenser fans because they're inexpensive to buy. Bathroom fans gonna have these in them. Condenser fans, evaporator fans sometimes in commercial equipment. Then we move into the split phase motors, which we're on the split phase motor. This is the wiring configuration is ISIR, which stands for induction start, induction run. Okay, it starts through induction on the start winding and it runs on the run winding. It has medium starting torque and medium running efficiency. This is typical, would be a typical evaporative cooler motor.
Okay.
Okay? Just a single switch takes that start winding out of the circuit.
But it'll still be running, right?
Yep,
The
runs on the
induction
runs on the run winding. So common to run is where you're gonna get your power. It's gonna run on that. Wow. Okay. So we go into current relay. We talked about, remember the current relay? It works on the current of the run winding.
Oh,
This is basically the same thing. It's an ISIR, which is induction start, induction run, but it's using current relay instead of a centrifugal switch to take the start winding out. As you can see, we got L1, goes right through that run winding.
yeah. Other one.
So that run winding is that coil, which is in the current relay, is always in the circuit. So as soon as this thing tries to start, this thing's gonna pull that pin up and energize the start winding to give it more torque to start. See how simple that is? Pretty neat, pretty neat. Okay, the same thing, if we add a capacitor, now we have high starting torque and medium running efficiency. So we put a start capacitor in there, and now it's called a CSIR. So it's capacitor start, induction run, right? So it's gonna run on the run winding, and it's got still got the same current relay. It just added a start capacitor, gave it more starting torque.
Okay.
Gives a high starting torque. You see this in refrigeration units.
Like commercial type or residential? Commercial?
Yeah, some residential might have it too.
Mhm.
Okay, so the PSC motor, that stands for Permanent Split Capacitor Motor, has medium starting torque and good running efficiency. Okay, so this is gonna start with that run capacitor, putting the starting winding out of phase with the run winding. It gives it that little extra. It runs on the run winding. The run capacitor is always in the circuit all the time. So this is about 80% of the motors you're gonna see out there. Is this configuration right here. It's a PSC motor. It just requires one capacitor, and it's a run capacitor. You guys remember run capacitors, right? Okay. Not all the it's not the greatest. It doesn't have a lot of starting torque, but it still works. Okay.
Simple and good.
Okay, so now we're gonna move on to the better. This is good starting torque and good running efficiency. So this is called the capacitor start, capacitor run motor. Okay, as you can see, we have a current relay right there, current. It starts on, it's got a starter capacitor, and it's gonna start on the start capacitor with the start winding. This is gonna open up, and it's gonna run on the run winding once it's up to speed. Now, if you notice, there's a start, or the run capacitor is still wired inside that circuit. So it's in between the start and run windings is where you see that run capacitor. So it's basically, it starts out as PSC, and we add some stuff to it to make it a CSCR. Right? Because that capacitor is still in that circuit, right?
It starts as a what?
PSC, the last one, PSC. It's basically that. We've added a start components to that to give it some more starting torque. Okay. Now this wiring configuration is about as efficient as you can get with a single phase motor. This is another way of wiring it. This is with a potential relay. So you got the potential relay. Remember the terminals that are identified on a potential relay? 5, 2, and 1. So this potential relay down here, 5 goes to common, and start and common are measuring that voltage across the start winding. So it's sensing that voltage, and then between 2 and 1 are a set of contacts. And on this one, you've got a start capacitor. It's also going to be taken out of that circuit. Huh?
No, that shape.
Okay, so the start capacitor is going to be taken out of the circuit once those contacts open, once it's up to speed. Again, it's still going to run on that run capacitor. So it's basically PSC with a bunch of starting components on it. Okay? It's got good starting torque and good running efficiency. And they also call it hard start. Okay? Sometimes we'll have to do that in the field. Sometimes we will have this on a compressor. Just a single capacitor. And the compressor is having a hard time starting. You can hear it. Not starting very well. So what they do out in the field is they put on a hard start kit, or it's a capacitor with a universal relay, and they just wire it right here to here to here. The problem with those is they don't last.
You got a little Chucky out there.
Huh? They don't last. They have a tendency of failing. Okay, so what I would do is I would keep one of those devices on my truck, and I would check and see if, especially if the compressor didn't start, I would hook that hard start kit up to it and see if I can get that thing going. If it does start, then I will call the supply house and get the model number of that compressor and tell them that I want the start components for that compressor. I'll give them the model number of the compressor, and they'll get me a new run capacitor, start capacitor, a potential relay, and probably a new contactor. And I'll replace all of those components on that, and I turn it into that. So with all the new components on it, now I know it's gonna start, I'm not gonna have a problem. Okay, it costs more, but it's what the manufacturer is designed for. So the manufacturer is gonna give you those components, they're gonna give you all the parts that are required for wiring a hard start, if you need to. So, they don't recommend putting a hard start kit on the universal, because they do fail. This will last a lot longer, it's better, and it's what the manufacturer is actually saying you should do. Plus, you've already sold more parts, and you've done it right. That's why I always ask the customer. I said, I could just put a capacitor on there, cost you this much, but, if you want it done the way the manufacturer wants to design that compressor, I'll need to
So
get
the
there.
proper way, I guess you
The
could,
proper way, yeah.
not the Mickey Mouse way.
Yeah. And most of the time, the customers go for it. So even though you're spending more, and I also replaced the contactor, which means, everything that's involved in starting that compressor has been replaced, it's all brand new.
So you shouldn't have that problem for a while.
Probably have no problem at all. You actually increase the life of that compressor, because it wasn't starting before, let's say, it just wasn't gonna start. Now you got it up and running, and it's starting good, it's starting way better than it used to, and, if you can get it started. So you've increased the life of that compressor. This is what happens, if people will go out, technicians, like you guys, will go out and they'll fire that compressor up and it doesn't start. Oh, you need a new compressor, not starting. Then I'll go out there and I'll go, let me check it. Let me go in there, let me see what I can do. When I say let me see what I can do, I usually end up fixing it. So, I'll put the components on, I'll check it, and I'll put the components on, and I said, now, you get a compressor just like brand new. I can't guarantee how long it's gonna last, but it's working right now, and it sounds really good. It's pumping like it's supposed to, and it's doing everything it's supposed to. And I become a hero, cause, you're looking at maybe $300 compared to $2,000.
Yeah, that's a big difference right there.
And you probably gained a customer. And the other company probably lost a customer. Okay? So the last one is the three-phase. As you can see, there's no start windings. There's only run windings in this motor. It's got 3 separate windings, run windings, L1, L2, and L3. And like I said before, that thing locks into that three-phase current and it takes off and it runs. So it's the most efficient motor out there, outside of a VFD, one with a VFD on it. And the variable frequency drives will only work with three-phase. The ECM motors that we talked about before, they're for single phase and they're for 1 horsepower or less. The three-phase motors go all the way up to 100, 200 horsepower. Okay? You guys like that?
So far, so good.
Okay. That was it?
Come on, Steve, you got my hopes
That was
up.
exciting. Okay, so